All right, let's dive right in. We are about to take a journey to the absolute edge of what we know, to a place where space, time, and, well, the laws of physics themselves just completely fall apart. Today, we're talking about one of the most extreme, most mysterious objects in the entire universe, the black hole.
So what even is a black hole? I mean, really, it's a truly insane amount of stuff crammed into a space that's way, way too small. Physicists actually have a name for this tipping point, the Schwarzschild radius. It's basically the size you'd have to crush any object down to for it to become a black hole. Now, to make that real for you, imagine taking our entire planet, every ocean, every mountain, all of it, and squeezing it down to the size of a marble. Yeah, a single marble. At that point, its gravity would be so powerful that nothing, and I mean nothing, not even light itself, could ever escape. And that, right there, is the heart of what a black hole is.
To really get our heads around these cosmic monsters, let's pretend we're astronauts. We're on a mission, flying towards one. We're going to take a guided tour of this abyss, checking out its key parts one by one from the outside all the way in. So, buckle up.
Okay, so our little journey has three main stops. First up, we're going to hit the accretion disk, which is this brilliant, violent ring of light. Then we get to the really famous part, the point of no return, the event horizon. And finally, we're going to talk about what's waiting at the very center, the singularity, the place where physics as we know it just stops.
Now, the first thing you notice as you get closer, and this might surprise you, it isn't darkness. It's an incredible, blindingly bright light. This is the accretion disk. Think of it as a giant, swirling whirlpool of superheated gas and dust, basically the leftovers of stars and planets that wandered a little too close. This stuff is spinning at a huge fraction of the speed of light, and the friction, it generates so much heat that this disk glows brighter than entire galaxies. It's just an incredible sight.
So we push past that glowing disk, and we approach the most famous, and maybe the most feared, part of the black hole, the event horizon. Now, this isn't some physical wall you can touch. It's an invisible line, a true boundary. It's the point of no return. And it's defined by one simple, terrifying fact. Once you cross that line, the speed you need to escape is faster than the speed of light. And since nothing can go faster than light, well, you get the picture. Nothing ever comes back out.
This is where our little trip gets, well, let's just say it gets intense. We're not just going to talk about crossing the event horizon, we're going to explore what that crushing gravity would actually do to your body. And the process has this weirdly casual name for something so completely horrifying.
So what happens if you actually fall in? You've crossed the line, you're past the point of no return. What would that actually feel like? What is the physical experience of being pulled apart by the single most powerful gravitational force in the entire universe?
Okay, so here's the key. The gravity isn't pulling on your body evenly. Let's say you're falling in feet first. The gravitational pull on your feet would be unimaginably stronger than the pull on your head. And that massive difference in force, just over the 6 feet of your own body, is what's known as a tidal force. And that's the beginning of the end.
And this is the result. Those insane tidal forces would grab you and just stretch. You'd get pulled longer and thinner, kind of like a piece of pizza dough, until your body was literally stretched into a thin little stream of atoms. And scientists, in a moment of brilliant and gruesome clarity, call this process spaghettification. A chillingly perfect name, right?
But the weirdness of a black hole doesn't just stop at, spaghettifying you. No, it fundamentally messes with the very fabric of reality itself. And that includes time. This is where we leave sci-fi behind and get into some truly mind-bending but totally proven physics.
It all comes down to this core idea from the man himself, Albert Einstein, and his theory of general relativity. Gravity warps space. You've probably seen the bowling ball on a trampoline analogy. And because space and time are fundamentally linked in what we call space-time, that means massive gravity also warps time. The rule is simple. The stronger the gravity, the slower time ticks.
So let's imagine your friend is watching all this happen from a safe distance, back on the ship. As you get closer and closer to that event horizon, they would see your clock and all your movements start to slow down. You'd look like you were in slow motion. Slower and slower, until, from their perspective, you'd seem to just freeze right at the edge, forever. But here's the crazy part. For you, as you're falling in, time would feel perfectly normal. The consequences are just staggering. 1 minute passing for you could be 1,000 years for everyone you left behind.
We've gone past the glowing disk, we've crossed the event horizon, we've seen time itself bend and warp. There's only one destination left on our tour: the absolute center, the place where all that matter has gone.
At the very heart of every black hole, there's the singularity. This is it, the end of the line. It's a point where the mass of an entire star, or maybe millions of stars, has been crushed down into a region with zero volume, which means it has infinite density. And at this one single point, all of our known laws of physics, general relativity, quantum mechanics, the whole shebang, they all just completely break down. We simply don't have the words or the math to describe what's happening here. It is, quite literally, the end of physics as we know it.
This is the ultimate unknown, right? A place where our science just stops and mystery begins. So I'll just leave you with this one question to think about. If you could be guaranteed absolute safety, no spaghettification, and you could get one single glimpse of what lies at the singularity, the place where the rules of our universe no longer apply, would you take that look? What do you think you'd even see?